This is our fourth and should be our final installment of our lecture on time value money. So we've covered the basics of time value money. We've covered the basic type of problem where you solve for present value, future value, in or interest rate, and then we covered annuities. This is the last problem we did on the last lecture. Let's skip ahead to the next one. This is called a perpetuity. It says if you acquire 10% return, then how much should you pay for an investment that gives you $1,000 each year forever? The key here is forever. Just because you get $1,000 forever doesn't mean it doesn't have a price, a present value that you should pay for it, because with discounting it converges to a set number. So there's actually a formula for this, but before I show you, one way to do this, if you can't remember the formula or you can't find it on the formula sheet, is just go to your calculator and plug in these numbers. So you have $1,000 per year at 10% interest rate forever. You can't put infinity into your calculator, but you can put a really, really large number if you want. Just go over here to your calculator and type in, for n, as many nines as you can fit in the screen. That's going to basically give you the right answer when you solve for present value. When you hit compute present value, it'll be as close to the right answer as you need to be. So let's do that real quick. Sorry. Plug this into my calculator. So if I plug all that in, I get $10,000. So that's how much you should pay for a $1,000 payment forever. There actually is a formula for this. The perpetuity formula is really simple. It's the payment divided by the interest rate. If you divide $1,000 by 10% or $1,000 by 0.1, you'll get $10,000. That's the formula for a perpetuity. Exactly. But again, if you can't remember it, you just plug in a whole bunch of nines for n on your calculator, and it'll give you the right answer. Alright, we're going to move on now. Perpetuities are kind of similar to annuities, just infinite life. Now we're going to move into... First we're going to do perpetuities with constant growth. Then we'll move into what we call an uneven stream of cash flows, where we can't use our gray buttons. We're going to learn to use the row above the gray buttons. But first, let's look at perpetuities with constant growth. If you acquire 12% return, how much should you pay for an investment that gives you an annual income stream that grows at 5% forever, with the first payment being $100? There's a formula for this one. It's written right here. Present value equals cash flow next period. The sub 1 means next period's cash flow. So the way the math works out, you don't use the cash flow that was just paid, the next one, over the interest rate, which I'm putting an I here. Sometimes I use a K for interest rate. That's standard in finance textbooks. Sometimes you use an R, sometimes an I, but I just means your required rate of return, your interest rate, minus G is your growth rate. So if we go back to the problem and look these numbers up, it says our first payment will be $100, so that's CF1. That's cash flow in one period in the future. It says our required return I is 12% and our growth rate's 5%. So if I plug all that in, I get 100 is cash flow at year 1 over 12%. When you run an equation and you're not putting it in your gray buttons in your calculator, you have to actually use them as decimals. So that'll be 0.12, not 12. And this will be 0.05, not 5. So 100 divided by 0.07, when you subtract those two, is 1,429. So this formula we'll use, this is a growing perpetuity. It's a perpetuity that grows at a certain rate each year. We'll use this in lots of different applications throughout the semester. One is inflation. Things grow, payments tend to grow at the rate in inflation. So G would be the rate of inflation. So you can put the first year's payment, how much it's going to grow each year due to inflation, your interest rate, and you'll get how much equivalent, the price. Present value, again, is like a price. How much should I pay for that security? We'll use them for pricing stocks, for example. Stocks tend to pay out cash flows that grow at a constant rate, at least large stocks do that have been around for a while. New stocks tend to grow abnormally fast, but stocks that have grown into their full size will grow at a constant rate. And so we can put that growth rate down there, how much we want to earn on it, the current dividend it's paying or cash flow it's paying out, and we can figure out the price of the stock. So that's growing perpetuities. They last forever. The payment grows at a constant rate. We can also do annuities that grow at a constant rate, but that's less common. We'll deal with that maybe later in the semester. It's not that hard to do, but we're not going to do it here. All right, next problem. Present value of an uneven stream of cash flows. So it says if you require an 8% return, how much should you pay for an investment with the following cash flows? Year 1, 100, year 2, 500, and year 3, 1,000. We can't plug these into our gray buttons on our calculator, the N, I/Y, PV, payment, and FV, because they don't fit this mold. They don't fit our typical mold that looks like this. But we have another way to deal with it, and our calculator helps us do that. And so that's what we'll talk about. So the way to do this is on our calculator, right above the gray buttons, there's 3 other buttons we'll use a lot in this class. One says CF, it stands for your cash flow workbook. That's where we put in these uneven stream of cash flows. And then next to it's NPV, that stands for net present value. That's how we'll calculate a present value of those cash flows we plug into here. And then there's an IRR, which stands for internal rate of return. All that probably sounds like gibberish right now, but you'll learn it as the class goes on. If you hit this CF button, it brings up what's called a workbook, which is, once you hit it, the first thing it'll probably say is CF0, that's what it should say, equals, and then it probably has 0 over there. It might have a number in there. First thing you want to do when you open up this workbook is hit second clear work. So you hit second, and then down here right above the clear button it says clear work, and it resets it to 0. It gets all your old information out of there. This is a workbook, which means you can scroll up and down to go to different years' cash flows. Up top you'll see it says enter, and then it has 2 arrows. The arrows mean you can scroll up and down. The arrows are right here. This is what allows you to scroll up and down. So for example, if you scroll down, it'll go to C01. C01 means cash flow in year 1. Scroll back up, CF0 means cash flow in year 0. In this particular problem, it's going to give us year 1, 2, and 3 cash flows, and we're solving for what's the equivalent year 0 cash flow. So we're not going to put anything in year 0. We're going to use the NPV button right next to it to solve for year 0. That's what we're looking for. What price should we pay for these 3 cash flows? So we're going to go to our calculator. We're going to hit CF. It's going to say CF equals 0. We're going to scroll down 1. It's going to say C01. That's cash flow year 1. We want that to be 100. So I type in 100 and I hit enter. The enter button's right here. And it'll put a little triangle over the top of it up here that says you've saved it. And you scroll down. The next thing you'll see is an F01. Just scroll past the F's. They should say 1 all the time. And as long as you cleared your work, they'll always say 1. That stands for frequency. We'll rarely use that in this class. You can look at your calculator manual to figure out how to use those. Just scroll down to C02. That's the second year. Second year is supposed to be 500, so we'll type in 500 and hit enter. And it saves it. And then we'll scroll down to the third year, and it was supposed to be 1,000. So we'll hit 1,000 and hit enter. And I like to go back and check. So you scroll back, and C01 I have 100, C02 I have 500, C03 I have 1,000. Then you hit the NPV button right next to it. That stands for net present value. You put in your interest rate. If we go back and look at our problem, our interest rate was 8%. So once you hit NPV, it says I equals. That's where you put in your 8%. Hit enter. Again, it saves it. And then again, it has the arrows up here. That means it's a workbook. You can scroll up and down. Scroll down 1. It says NPV equals. It also says compute up here. You hit the compute, upper left-hand corner, and it'll give you the NPV. And I'm getting 1,315.09 cents. So if you do it right, you should get 1,315.09 cents. And that's how you find the present value of an uneven stream of cash flows. A uneven stream of cash flows just means a stream of cash flows you can't put in your gray buttons. So it's not like a perpetuity where you have the same payment each period. But you can still calculate it with your calculator. You just have to use that cash flow workbook. Future value of an uneven stream of cash flows. What is the future value in year 3 of the cash flow stream mentioned above? So we're going to use these same cash flows, but we don't want the present value, we want the future value. So in other words, what if we were asking the question, if I were to put in $100 in year 1, 500 in year 2, 1,000 in year 3, how much would I have at the end of 3 years? This question is a little ambiguous. It's asked for the future value. Oh, there, actually, I'm wrong. I wrote in there in year 3. Meaning, we just basically want to take that present value and move it 3 years in the future. So the present value was $1,315. We want to find what that's worth 3 years later at an 8% interest rate. Well, this is just a straight time value money problem. I take my $1,315.09. I want to move it 3 years in the future. Sorry, this shouldn't say 1,000. It should say 0. We have no payment. We basically have one. We're going to invest one amount today. It's $13,015. We want to know what it's worth 3 years later. That's what this problem is asking. You can't really find a future value of an uneven stream of cash flows with the standard finance calculator. There's more complicated versions that it costs more. There's more expensive versions of this calculator that'll find future values of uneven streams of cash flows. I'll assume you don't have that. If you do have it, then all you do is just, instead of hitting net present value, hitting net future value, and it'll just solve it for you immediately. But with the standard calculator, we can still find that answer. We just need to take that present value and move it 3 years into the future. That's all, at an 8% interest rate. That should be what the future value of those 3 cash flows were. So let's plug that into our calculator. And I'm getting 1,656 and 64 cents. So one way to look at this problem is just a simple time value money problem. What's the future value of $1,315 3 years later at 8%? Or another way to look at it is, what's the future value of, if I were to put $100 in year 1, 500 year 2, and 500 in year 3, how much would I have in my account at the end of those 3 years? Okay, so it's just a different type of problem. Alright, I think this is our last problem. Yeah. So, solving for the interest rate of an uneven stream of cash flows. Say you paid $1,000 to receive the cash flow stream above. What interest rate did you earn? This is where we'll use, if I look at my calculator one more time, we'll use the IRR button. IRR stands for internal rate of return. What it's going to do is it's going to take all the cash flows you put into your cash flow workbook, and it's going to back out what interest rate equates all those to 0, meaning it's a break-even investment. So when we put these cash flows in there, we put 0 in for year 0. Now we're going to put in whatever we paid for the investment in year 0. Which, if we go back and look at the problem, says you're going to pay 1,000. So you're going to hit cash flow workbook. It's going to bring up the workbook. You should still have the same numbers you had in before. So for year 1 you have 100, for year 2 you have 500, for year 3 you have 1,000. But we're going to now put a number in for year 0, and it's going to be $1,000, but it's going to be negative 1,000 because you paid it. So you put in negative 1,000 for year 0 and hit enter. When you pay something out, it's a cash outflow. It needs to be negative in your calculator. But now you hit IRR, the IRR button right here. It says IRR equals, but up in the upper left-hand corner, it should say compute. Hit compute, that's this button right here, CPT, and it'll calculate that for you. And it's 20.44%. So if you happen to pay $1,000 for these 3 cash flows, you're earning about a 20.5% return. So what these upper buttons give you is an opportunity to calculate basically all the same stuff you can calculate down here, but for a sort of a non-conventional set of cash flows. If you have a straightforward set of cash flows where you have a present value, a future value, and a payment, then you can use the gray buttons. When you don't, when you have an uneven stream of cash flows, then you need to use the cash flow workbook. If you're solving for a present value, use MPV. If you're solving for an interest rate, you use IRR. Alright, we're about out of time here, so this is going to end our time value money lecture. Next will be a lecture on interest rates.